All right, so today we're going to focus on hydrostatic forces on angled surfaces. And here's the water line. And here's the free surface. And actually, let me pick a different color. This is still H. The angle here we'll call theta. And let's do this orange again. The center of this we still call HC. Okay, it's a centroid straight down from the free surface. Go ahead and draw that, and then we'll label some more stuff. So if I label a hydrostatic force, we know it's going to be down below. Is it going to look like that? No, because pressure force is always perpendicular to the surface. So that technically is wrong. It should be something like this, right? Where this is a 90 degrees. Okay. So that force, which we call FR, is acting perpendicular to that angled surface. Okay? Always, because it's a normal force. That's what pressure is. Therefore, if we draw this now up, and I'm just going to move this here. This is HP. What we need to do now is develop a new coordinate system. Okay. And is that color okay? So now we're going to go along that angle, and we're going to label these as YC and YP. So this direction now is Y. I don't like that. That looks bad. Got a nice sketch going. I don't want to mess it up. So this direction is Y. Okay, and let's do one more. The whole length of this is L. Okay. So the length of that angle that the water is touching is L. So how do we relate HC and YC together? What do we use? Yeah, we use trig. Yeah, we'll use trig. So let me draw this over here for you. Actually, I can probably do it underneath. This is YC. This is HC. Here's the angle. So therefore, sine of theta is HC over YC. So HC, move up a little bit more, is YC times sine theta. And to keep it consistent, then HP is just YP sine theta. Typically, the length of that angle is given, and the angle is given. So you have to figure out HC, because that's used to find the average pressure. Okay, so let's write some steps. Step 1. Write the FR equation. So what's FR? Yeah, what's the equation? P average times A. Step 2. Find P average. P average equals rho GHC. Just going to zoom out a little bit and reiterate something right there. I think everyone can see that. How come when we find this pressure, we don't include this top pressure, which is atmosphere? Yes, it's also acting on this side, pushing up, and they actually cancel. So we eliminate a whole bunch of steps when we do our free body diagram. Okay? Good. All right, and just to save room, I'm going to write step 3 over here. This would be sub numbers. Okay, so FR equals blah, blah, blah. Step 4 would be to find HP. And in this one, there's kind of 2 steps. First, you can find YP. Yep, I'll tell you in a second. That's the area moment of inertia. So this is an actual equation that's derived. It's in your book. They show you how to derive it. Don't worry about that. Just now know, in order to find the location of YP, you have to know YC, which is the centroid, the area, and this IC, which is your area moment of inertia. Okay, so I scroll over here. I have a rectangle. And we have these 2 dimensions. This is W, this is L. IC for a rectangle is WL cubed over 12. I'm pretty sure you've probably seen this before. Some of you have. Some of you may not. You do this in statics or strains? Strains. Okay. Are you doing this now? Strains? No? Okay. Well, you will. Okay. Don't worry if you don't. There's equations for it. So this area moment of inertia just talks about how this area is distributed in this shape. Okay? So it's just, actually, why don't we write it down? So IC is what they call the area moment of inertia. And it's basically talking about how well this area, or really the mass, is distributed in a rectangle. Okay. Rectangles. This is the equation you use. Circles, triangles, you name it. All shapes and sizes have a different distribution of mass around the centroid, and you just look them up in your book. Okay? So if this is a rectangular wall we're dealing with, we'd use that right there, WL cubed. That's a funny looking 3. It should be a 3 over 12. Yes?
I want to kind of bring this back to step 1. How do we find that area?
The area, yep. Okay, I am going to project so that is projected what the water's touching of that dam or wall. Okay, so whatever area the water is touching against that's the area you need to find. So you need to know this L here, and you need to know the depth in and out of the page. Okay, so that's your area for if it's a rectangle. Yep. Okay. Just going to erase those, confusing. So in and out of the page is your width or depth times the L will give you the area. That's what the water is touching on the surface. Good. Other questions? Okay, then part B is find HP. And that's where you use the sign. Now, for a rectangle, the HP will act 2/3 down L. Okay? But I gave you this YP equation because this is general for any shape. If it's a rectangle, if it's a circle, if it's a triangle, if it's a weird shape, okay, you can always use this equation and then find this. All right? So let's have a practice of numbers in your notes. So given so we have a dam that's 30.5 meters long, so it's the width. All right, it holds 8 meters of water, so the height is 8. The angle that it's inclined, so it's the sketch that we just drew, is 60 degrees. The density of water we know now is 1,000 kilograms per meter cubed, and we know we're going to need G. So if you notice, some of this givens like G and density of water, it's almost like, okay, we know we're going to use those. Might as well write them down so you know. What was what's the density of water in English again? Yep. Feet cubed, yep. Anybody tell their family the density of water yet? No? You have to. You got to record it. Send it to me. I'll give you bonus points. Sketch. It's, for now, see above in your notes. So on your homework, what do I expect? This beautiful sketch right there. And nice and straight. If I see it and it's not, I'm going to give it back to you. I might buy a stamp. Say unacceptable. And red. Give it back to you. I should have to. I make one. Might have to print. I can 3D print one. Okay, and we're finding FR and HP. So let's get to the solution. Oh, so let's find FR, and we'll use the hydrostatic force equation. So FR equals P average times A. And I'm okay now if you just say plug P average in. Rho G HC times A. And I'm going to go one more and say rho G H over 2 times A. So, and again, I'm okay if on the right you do small sketches, okay, and you kind of put some notes. So what I'm going to do is I'm going to do some trig over here. I'm going to call this L, this is H, and this is theta. Does everyone see that from your sketch? The height of the water, the length of the side of the incline. So down here, I'm going to do in black here. Sine of theta equals H over L, and L equals H over sine theta. Any guess why I want L? For the area, yeah. So, if you notice, now we can plug in A. So FR equals rho G H over 2 times W times L. And now we've defined what L was. We can plug that in like this. Now, looking at this equation, are all our givens on the right of this equation? The density of water is G is, I think H was, right? Yep. W, H, and the angle. So why don't we just sub this right now? Thousand kilograms per meter cubed times 8 meters over 2 times 30.5 meters times 8 meters over sine of 60. And make sure you're in degrees, not in radians. Oh, I did. Thank you. Easy when you do it with a pencil, right? Thank you. And double check. I think I got 11.06 meganewtons. You box your answer. Make sure you box again the variable with the number. And do correct sig figs for me. Don't give me 11,055,749.59 and box that. Okay, I will write on it. Huh? Sig figs. Okay. Questions so far? Okay, so next step is what? Let's find HP. HP equals YP sine theta. Find YP. YP equals YC plus IC over YC times A. Okay, and I'll find YC first, and that's using trig. So 8 meters over 2, sine of 60. And we get 4.62 meters. And I'll let you catch up. going a little fast. I see. Now, if you notice, there's a lot of things that you can find ahead of time, right? Kind of know. You can find IC, you can find YC, you can find the area. Have all that stuff up front, and then plug it down below. All right, so this is a rectangle. So it's WL cubed over 12. So we get 30.5 meters times 8 meters over sine of 60. And that's cubed over 12. The units. And the number I got 2003.5. And it's to the fourth. You do that. I'm going to find the area, which we kind of knew was what, W times H over sine theta. Plug this in your notes. 30.5 meters times 8 meters over sine of 60. We get this to be 281.75 meters squared. We're almost there, right? Question? No? Do we have the black writing? So if I go here, you won't yell at me? Okay. Now we can find YP, right? 4.62 meters plus 2003.5 meters to the fourth divided by 4.62 meters times 281.75 meters squared. Get YP to be 6.16 meters. And then finally, HP is 6.16 meters times sine of theta. Oops, sine of 60.